in question number 8, let's look at what we are given. From the diagram, you can see that there is an object, there is a force at an angle into the ground. So you can imagine that force of gravity, if I were to draw my free body diagram, force of gravity would be downward. That would be my mg. And then I would, instead of putting it like that, I would redraw that force into the ground like that. Now, if angle is right here, it's the same alternate interior, theta, like that. And now you can see that I have normal force greater than gravity by the push into the ground. So this right here, my normal force is going to be mg plus f sine of theta opposite. I see through that sign, right? And then frictionless horizontal table. Beautiful. Vertically in the OY direction, net force is going to be 0. But in the horizontal direction, my net force is going to be just F cosine of theta. So this is just old good stuff that we have looked at when we were studying forces. But this is about work. So let's look, what do they want from us here? So they give us the force, they give us the angle, and they give us the distance and the mass, and this is about work. So determine the work done by the applied force. So since they're asking for work, we're going to remember that the work formula is force, displacement, and the angle between those two vectors. So my force is into the ground, displacement is in this direction, horizontally. So the angle between them is theta. Okay? So then I would do work of the applied force is going to be force times d times cosine of theta, and I will put what they are giving me, 16 newtons for the force, 2.20, and then cosine of 25 degrees. That gets me 32 joules. So that's the answer to A. By the normal force exerted on the table, work is going to be force normal, whatever it is, times d times cosine of 90. Even if if they asked me to find normal force, I could have, but why bother if I know that this right here is going to be 0, and therefore work done by normal force is also going to be 0. C, the force of gravity, same thing. Force of gravity will be doing 0 work due to the fact that it's perpendicular to the displacement. Cosine of 90 is 0, so 0 joules. And then finally, work of net force is just, so if I look at my net force on x, it's going to be force times, applied force times cosine of 25, so 16 times cosine of 25, and then I would multiply that, 16 times cosine of 25, times the distance, which is 2.2. Well, that gets me the same answer, 32 joules. And why is that? Because if I look at my net work, I can find it as the work done by net force. And net force, like I said, in the x direction is just this force right here. So that would be 16 cosine of 25 times this distance of 2.2. Or I could add all the separate works. The work done by the applied force, the work done by gravity, the work done by normal, and I would still get 32. So again, 2 ways. You can find individual works done by individual forces, and then the net force, net work by adding those works together. Or you can find net force to begin with and just multiply it by displacement. And why is that? Because displacement is in the direction of the net force.